charges. This work done is stored as potential energy of that charges. Now these two charges are bringing in this coordinate system. So this is the potential energy of the system. So what is mean by electrostatic potential energy of system is defined as the total amount of work done by the charges brought from infinite distance to that system is called as a potential energy of the system. So now we are going to study electrical energy of a system of 2-point charges. Electric energy of a system of 2-point charges. So this is the XY coordinate system, and there are two charges, say Q1 and Q2 from the point O. This charge Q1 is at a distance R1 and this charge Q2 is at a distance R2 from the point O. Now this charge Q2 is at a distance R12. Is at a distance R12. We have to find out total electrical energy of this system. Now we have to consider this is a system because these two charges in this coordinate system, and we have to find out its electrical energy of this total system. So let's find out. Consider two charges. Consider two charges, say Q1 and Q2 are at a distance R1 and R2 from point O. Now initially charge Q1 is at infinite distance. So at a infinite means, for example, the charge is at this distance, and for the system this is at a infinite distance. We have to brought this charge at this point. So we have to do work done for bringing this charge from this point to this point. So total work done by the charge W1, because the charge is Q1, so we have work done W1 is equal to V1, which is equal to 1 upon 4 pi epsilon 0 Q1 divided by R1 for bringing the charge from infinite distance to in that system. So we know that W for work done, so work done is equal to electrostatic potential of that charge. So V1 is equal to 1 upon 4 pi epsilon 0 Q1 divided by R1. Now this point suppose B and this point is A. Now we have to bring the charge Q2 from infinite to point B. by the charge work done by the charge Q1 multiplied by charge Q2. So work done by charge Q1, that means V1, Q1 divided by 4 pi epsilon 0, 4 pi epsilon into R12, the total electric potential of this system is U is equal to Q1 Q2 divided by 4 pi epsilon 0 R12. We know that electrostatic potential is the electrostatic potential energy. U is equal to Q1 Q2 divided by 4 pi epsilon 0 R12. Suppose there is another point, say C. Another point, say C, for the charge Q3. For the charge Q3, we have electric potential for the charge Q3 is V3. We get this total work done for these two charges. U is equal to Q1 Q2 divided by 4 pi epsilon 0 R12. Because from charge Q2 is at a distance R12 from the charge Q1. Now for the charge Q3, from infinity to point C, from infinity to point C. Now this Q3 is at a distance R3 from point O, and from Q2 and Q1 it is at a distance R13. On the charge Q3, the electrostatic force is affected by Q2 and Q1. So, for charge Q3, the electrostatic potential or work done by on the charge Q3 is V3 is equal to Q is equal to 1 upon 4 pi epsilon 0 Q1 divided by R12 plus Q2 divided by R23 multiplied by the charge Q3. On this charge, these two charge force is acted. So we have 1 upon 4 pi epsilon 0 Q1 divided by R12, the distance, plus Q2 divided by R23 multiplied by the charge. So we get V3 is equal to Q1 Q3 divided by 4 pi epsilon 0 R12 plus Q2 Q3 divided by 4 pi epsilon 0 R23. This is the electric potential of the system if there is 3 charges Q1, Q2, Q3. Similarly, if there is a 4th charge, say Q4, for the charge Q4, the force is affected on the charge Q4 by Q1, Q2 and Q3. The total work done on the charge Q4 is 1 upon 4 pi epsilon 0 Q1 divided by R12 plus Q2 divided by R23 plus Q3 divided by R23. multiplied by Q4. So we get Q1 multiplied by Q4 divided by 4 pi epsilon 0 R12 plus Q2 multiplied by Q4 divided by 4 pi epsilon 0 R23 plus Q3 divided by Q4 divided by 4 pi epsilon 0 Q34. Suppose there is a n charge. For the charge Qn, for the charge Qn, suppose this is the charge Qn which is at infinite distance from the system, and if we want to plot this charge in that system, then the total work done by the system is given by 1 upon 4 pi epsilon 0. Brought from infinity to point, and we have 1 upon 4 pi epsilon 0 Q1 divided by R12 plus Q2 divided by R23 plus Qn divided by Rn. By the principle of superposition, we have total work done for the system is 1 upon 4 pi epsilon 0 summation of Qj into Qk divided by Rj into K. For the total system, we get electric potential energy is 1 upon 4 pi epsilon 0 summation of Qj Qk divided by Rj into K. This is the total electric potential energy of the system. So, we have to find the equation for the electrical energy of the 2 point charges in that system. Means we get total energy for that system, bringing the charges from infinite distance to finite distance by addition of the total electrical potential, and we know that electrical potential is the work done by the charges. So next point is potential for potential energy, of a single charge in external field. Suppose this is the external field, external electric field. Its direction is in this, and the charge Q is at infinite distance. This charge, if we bring this electric field, there is a work done by the charge, and if this distance is R1, if the charge Q, this distance is R, and we want to bring this charge in this external field. This external electric field is unknown for this charge, and if we brought this charge in that external field, we get the electrical potential potential energy due to this work done by the charge, and this potential energy is equal to Q multiplied by electric potential at a distance r, therefore we write here I. Potential energy bringing the charge Q from infinity to an external electric field. हा जो चार्ज आहे तो चार्ज आपण एक्सटर्नल इलेक्ट्रिक फील्ड मध्ये आणलेला आहे. सो पोटेन्शियल एनर्जी बाय द चार्ज इज इक्वल टू Q value of Q multiplied by electric potential by the charge. So we get potential energy is equal to Q into VR. That is potential energy of a single charge. फक्त एका चार्जसाठी एक चार्ज आपण काय केलेला आहे तो एक्सटर्नल फील्ड. या चार्जसाठी एक्सटर्नल फील्ड जे आहे ते काय असणार आहे अननोन असणार आहे. या अगोदर आपण जे काही इक्वेशन फाइंड आउट केलेले आहे ते इक्वेशन या चार्ज पासून जे काही इलेक्ट्रिक फील्ड क्रिएट होते त्या इलेक्ट्रिक फील्डची पोटेन्शियल व्हॅल्यू आपण फाइंड आउट केलेली आहे. पण हा जो चार्ज आहे तो जर आपण एक्सटर्नल दुसऱ्या एखाद्या एक्सटर्नल फील्ड मध्ये ठेवला तर त्यावर तिथे काही पोटेंशियल एनर्जी मिळते. ती पोटेंशियल एनर्जी काय असणार आहे पोटेंशियल एनर्जी इज इक्वल टू मॅग्नीट्यूड ऑफ द चार्ज मल्टिप्लाय बाय इलेक्ट्रिक पोटेंशियल ऑफ दैट चार्ज. So next point is potential energy of a system. Potential energy of a system. Potential energy of a system of two charges in an external field. In an external field. We find this equation for a single charge. If suppose there are two charges. Suppose this charge Q1 and another charge say Q2. And we want to bring these two charges in another external field. Then we have to we get potential energy of a system of the two charges. So let's find the equation for that. Work done by the charge. Work done by the charge Q1. Work done by the charge Q1 is equal to Q1 free R1. For the charge Q1, this distance is R1. So we get potential energy Q1 into free R1. Now this is the equation number 1. Suppose the another charge is Q2, and when we bring the charge Q2 in this external field, then this external field will give force on the charge Q2, and also the charge Q1 also force on the charge Q2. Means on the charge Q2 we have get two forces, this external force and due to charge Q1. So work done by the charge Q2, work done by the charge Q2 is Q2 into free R2. It's initial work done, and when this charge is in external field, then this Q1 also act on that charge Q2. So work done on charge Q1 is Q1 phi R1 plus Q1 Q2 divided by 4 pi epsilon 0 R1 2. Because this charge Q1 and Q2 is at a distance R1 2, so we get Q1 Q2 divided by 4 pi epsilon 0 R1 2. This is the equation number 2. Equation number 2. So total electric force on these two charges we get Q1 phi R1 plus Q1 Q2 divided by 4 pi epsilon 0 R1 2. This is the total work done or total potential energy of two charges by the system, and by the principle of superposition we get Q1 phi R1 plus Q1 Q2 divided by 4 pi epsilon 0 R1 2 plus Q2 into phi R2. This is the total energy of the total potential energy of a system of two charges in the external field. On these two charges, the electric potential due to Q1, electric potential due to Q2, and both the charges Q1 Q2 divided by 4 pi epsilon 0 R12. So total potential energy of the system is Q1 phi R1 plus Q1 Q2 divided by 4 pi epsilon 0 R12 plus Q2 into phi R2. So the next point is potential energy of a dipole. Potential energy of dipole in an external field. In an external field. Suppose this is the external field vector E, external electric field vector E, and there are two charges, say plus Q and minus Q. Due to this plus charge, we get its electric force of attraction or its electric force in this direction, and due to this minus Q, we get electric force in this direction into theta 0. So W is equal to PE common, and integration of sin theta is minus cos theta theta 0 into theta. So we get PE, substitute this limit, minus cos of theta 0 minus becomes plus cos of theta. So PE cos of theta minus cos of theta 0. We get total work done by this couple or by this torque. W is equal to PE cos of theta minus cos of theta 0. So stop here, and next point we'll see in the next lecture. Thank you.